Our subject motto is Mathematics Made Simple. In our previous lesson, we looked at a square as a product of an identical factor multiplied by itself twice, and the square root of n as a number which when squared yields n. Now today we are going to look at our lesson 2, which are cube roots. Now you cannot find the cube root if you don't know what a perfect cubic number is. What is a perfect cubic number? A perfect cubic number is a product of an identical factor multiplied thrice. So if you get a number and multiply it by itself 3 times, what you are going to get is a perfect cubic number. For example, 0 times 0 times 0 is giving us 0. 1 times 1 times 1 is giving us 1. 2 times 2 times 2 is giving us 8. 3 times 3 times 3 is giving us 27. 4 times 4 times 4 is giving us 64. 5 times 5 times 5 is giving us 125. 6 times 6 times 6 is giving us 216. 7 times 7 times 7 is giving us 343. 8 times 8 times 8 is giving us 512. 9 times 9 times 9 is giving us 729. 10 times 10 times 10 is giving us 1000. Now, those answers we have found, these answers after multiplying numbers by themselves 3 times, are what are known as perfect cubic numbers. Let's look at an example. We have an example. Determine whether the following are perfect cubic numbers. We have 64, 360, and 216. Now, the way we were finding square numbers is the way we are going to determine perfect cubic numbers using prime numbers. Prime numbers are used to determine perfect cubic numbers. We know what prime numbers are. Prime numbers are numbers divisible by 1 and the number itself only. So let's go to 64. We have 2 methods we are going to use. We'll use the table, the way we were doing it. So we'll say 2 into 64, 32, 2 into 32, 16, 2 into 16, 8, 2 into 8, 4, 2 into 4, 2, 2 into 2, 1. Then we express 64 as a product of its prime factors, which is 2 times 2 times 2 times 2 times 2 times 2. After that, what are we supposed to do? We'll group the factors. So when we group them, we'll get 2 times 2, which is giving us 4. So we have 4 times 4 times 4. 4 times 4 times 4 giving us 64. 4 to the power 3 is 64. Therefore, 64 is a perfect cubic number. Let's use the tree method. We have 64. We'll say 2 into 64, 32. 2 into 32, 16. 2 into 16 is 8. 2 into 8 is 4. And 2 into 4 is 2. Then we express 64 as a product of its prime factors by multiplying 2 times 2 times 2 times 2 times 2 times 2. After that, what are we supposed to do? Group the factors. We'll group the factors. 2 times 2 is giving us 4. So we have 4 times 4 times 4, giving us 64. 4 to the power 3 is 64. Therefore, 64 is a perfect cubic number. We go to example B. We have 360. We have a table. 2 into 360 is giving us 180. 2 into 180 is 90. 2 into 90 is 45. Then we go to 3. 3 into 45 is 15. 3 into 15 is 5. And 5 into 5 is what? 1. We express 360 as a product of its prime factors. 2 times 2 times 2 times 3 times 3 times 5, giving us 360. Can those be grouped? No, they cannot be grouped. Therefore, 360 is not a perfect cubic number. There's no number which we can multiply by itself 3 times to get what? 360. Let's go to the tree method. We have 360. We'll say 2 into 360, 180. 2 into 180 is giving us 90. 2 into 90 is 45. 3 into 15 is 3 into 45 is 15. And then 3 into 15 is 5. From there, we express 360 as a product of its prime factors by multiplying 2 times 2 times 2 times 3 times 3 times 5. Can those be grouped? No, they cannot be grouped. Therefore, 360 is not a perfect cubic number. Let's go to example C. We have 216. We'll use our table. 2 into 216 is 108. 2 into 108, 54. 2 into 54, 27. 3 into 27 is 9. 3 into 9 is 3. 3 into 3 is 1. Then we express 216 as a product of its prime factors. After that, we are going to group them. 2 and that 3. 2 and that 3. That 2 and that 3. So that we have identical factors. So we have grouped them. If you multiply 2 times 3, you get 6. So we have 6 times 6 times 6, giving us 216. 6 to the power 3 is 216. Therefore, 216 is a perfect cubic number. Let's go to the tree method. We'll start. 2 into 16 is 108. 2 into 108 is 54. 2 into 54 is 27. Then 3 into 27 is 9. 3 into 9 is 3. We'll express that as a product of its prime factors. And then we'll group them so that they are identical. 2 times 3 is giving us 6. 6 times 6 times 6 is giving us 216. 6 to the power 3 is 216. Therefore, 216 is a perfect cubic number. Now, what is a cube root? So, we are looking at cube roots now. The symbol, that one, this one is a cube root, means cube root and power 1 over 3. The cube root of n is a number when cubed yields n. For example, the cube root of 8 yields 2, meaning when you cube 2, when you multiply 2 by itself 3 times, it's supposed to give us what? 8. Let's go to an example. We have find the following: the cube root of 343 and B, the cube root of 729. So we'll still use the table. First, we have the cube root of 343. Now, for us to find the cube, we have to first check if 343 is a perfect cubic number. So we'll start by dividing 7 into 343 is giving us 49. 7 into 49 is giving us 7. 7 into 7 is giving us what? 1. So if we multiply 7 times 7 times 7, you get 343. 7 to the power 3 is 343. So where there's this 343, the way we were looking at the square root where we were substituting, we are going to substitute 703. Now, since cube root, this symbol means 1, the power 1 over 3, we are going to multiply the indices, we'll multiply the powers. So we are going to multiply 3 times 1 over 3, which is going to give us a common factor 3. 3 into 3 is 1. 7 to the power 1 is 7. So meaning the number which you are supposed to multiply by itself 3 times to give us 343 is what? 7. Let's go to the next example. We'll use the tree method where we'll say 7 into 343 will give us 49. 7 into 49 is 7. 7 times 7 times 7 is giving us 343. 7 to the power 3 is 343. So what are we going to do? We'll substitute. Where there's 343, we'll put a 7 over 3 and multiply the powers. When we multiply the powers, we are getting 3 times 1 over 3, which is giving us a 3, a 1. 7 to the power 1 is the same as what? 7. Let's go to the next example. We have the cube root of 729. So this symbol, cube root, means power what? 1 over 3. So we now have to find out whether 729 is a perfect cube or a perfect cubic number. So we'll use the table. 3 into 729, 243. 3 into 243 is 81. 3 into 81 is 27. 3 into 27 is 9. 3 into 9 is 3. 3 into 3 is 1. So we express that as a product of its prime factors, and then we are going to multiply them. So group them. 9 times 9 times 9 is giving us 729. 9 to the power 3 is 729. So where there's 729, we are going to do what? Substitute or replace a 9 to the power 3. Using the index of an index, we'll multiply the powers. 3 times 1 over 3 will give us what? A 1, which is 9 to the power 1, which will give us a what? A 9. As simple as that. So this is your exercise. The first question is determine whether the following are perfect cubic numbers. The first one, A is 480 and B is 1000. Question 2, find the cube root of 512 and B 2744. I hope to see your solutions